Okay, 6.4, similar and congruent figures. Okay, a similar figure is a figure that has the exact same shape but different size. Okay, so if I had, say I had a triangle that looks like this, that was 3, 4, and 5. Then I had a triangle that looks like this, that was 9, 12, and 15. Okay. Now, if this angle and this angle were the same, this angle and this angle were the same, obviously these two are both 90 degrees. So it would be, they look kind of the same, don't they? Right? They kind of look the same, right? So each one of these would have to have the same ratio, right? The corresponding part to this guy would be this guy. The corresponding part to this guy would be this guy. And this guy would be this guy. So the ratio for the corresponding parts are, this is 4 and 12, right? So 4 to 12. This guy is 3 to 9. This guy is 5 to 15, right? And this guy is the same as 1 to 3, 1 to 3, 1 to 3, right? Okay, so they have the same ratios. Okay, so in this situation, we would call this a similar triangle. So triangle ABC is similar triangle DEF. Okay, and the way we notate that is ABC similar to triangle DEF. Okay, now notice each corresponding part, so AB, the corresponding part to AB would be what? DE, correct? So AB to DE, right? AC, which would be this guy, AC, the corresponding part should be D to F, DF, right? Okay, so each point corresponds to the corresponding point. In other words, you cannot say that ABC is similar to DFE. Because if you do that, you would assume that AB and DF are corresponding parts, right? AB is not the corresponding, this is not the corresponding part, is it? No, right? So you can't say, so in other words, they have to be in exact order. Okay, does that make sense? So this would be DEF. So you have to be very careful when you write a similarity statement. Okay. Now, if I had a triangle that was actually exactly the same, okay, so if I had a triangle that looked like this, where this and this angle are the same, this angle and this angle are the same, and it was 3, 4, and 5, and again we'll call this DEF. Okay, then this time, since the ratio is exactly the same, I have 3, 4, 5, and I have 3, 4, 5 here. These are actually not similar, they are exactly the same, correct? And that's what we mean about when we say congruent. Okay, that's what we mean when we say they are congruent. So the congruent statement would be A, B, C. Again, we have to make sure we have the same counterparts, right? So the counterpart to A would be what? Over there, anybody? Which point would it be? F, right? It would be F, right? A would be F, B would be E, the other one would be D, right? When we notate congruent is that we go like this, okay? So we call this triangle ABC is congruent to triangle FED. Okay. All right, so if you go to page 300, in the middle, there is a shaded area there that says properties of similar figures. Go ahead and read that. See if that makes sense to you. Okay. So as you say, number one, you can see where the angles are the same. And number two, the ratios of the lengths of the corresponding sides are equal also. Okay. So example number one, we have LMN. LMN, and then we have over here a smaller PQR. Okay. So given that they are similar, name the corresponding angles. And so what is the corresponding angle to angle N? Can anybody tell me which one that would be? R. It would be R, right? It would be R over here. Good. L. P. L would be P. Good. Q. And then this guy would be the one that's left over. It would be Q, right? So M and Q would be the same. All right? Okay. And the sides, so RQ would be what?
Would be NM.
NM, exactly. Or actually, you could just look at the statement, right? Look at the statement, and you can say MN must be QR, correct? Right? Or you can say LN has to be, if you look at the statement, LN has to be PR, and you can just read it off the statement, really, actually. Okay? Right. That's example number one. Look at example number two. Given that the quadrilateral ABCD and JKLM are similar, find the ratio of the lengths of the corresponding sides. Okay, so let's go ahead and find out AB. What is the corresponding part to AB? Look at the statement. Read it off the statement. What is it?
JK.
JK, right? So we have AB over JK, and we'll just look at that ratio, right?
Mr. Ron?
Yeah.
How are these similar? There's like, doesn't they have to, I'm confused because then.
Yeah, if you rotated JKLM to the left 90 degrees, counterclockwise.
The lengths don't fit together though.
What do you mean?
For BC, it's 2 feet, and for KL, it's 3 feet.
Correct. So they're not congruent. They're similar, right? And that's what if you look at the statement, it says they are similar, not congruent there. Okay. So AB was equal to what? What is AB? AB was 8 feet. And JK was 12 feet. So this would be what? 2 over 3 if you divide top and bottom by 4. Okay, so the ratio of the lengths would be 2 to 3, right? 2 over 3. Okay. Example number 3, a soccer field is a rectangle that is 70 yards long and 45 wide. The penalty area is a rectangle that is 35 yards long, 14 yards wide. Is the penalty area similar to the field? If they were similar, they would have to have what? The same ratio, right? So example number 3, then 40 to 70 would have to be equal to 14 over 35, right? And this is kind of like what you did in the test, right? You had to see if they were the same proportions, correct? And you did what? You cross-multiplied to see if they were the same, right? You cross-multiplied to see if they were the same. So is 40 times 35 the same as 70 times 14? This guy here is going to be 980, it looks like. This guy over here is going to be 20 times 70, so it's going to be that. So they're obviously not the same, correct? So they are not the same, which means that they are not similar, because they do not have the same proportions, correct? And flip the page, let's go to page example number 4. Now, example number 4, we're going to talk about we're talking about here about congruent figures, right? Congruent figures. And those are figures that are exactly the same. Given A, B, C, D is congruent to W, X, Y, Z, find the indicated measure. Find the length WZ. WZ would be the same as what? Look at the congruence statement. If you look at the congruence statement, WZ is the same as Cooper, which one? Huh? Look at the statement. Look at the statement. The statement says, right? A, B, C, D is congruent to W, X, Y, Z. So I need the corresponding part to WZ. WZ would be corresponding to what over here?
WZ would be AD.
AD, correct. So looking at AD. So what is it? Elijah, what is AD? Is 12. So AD is equal to 12. Okay, 12 meters, right? B, angle W, which would be what? The congruence, would be what angle, which angle would that be over here? What?
BC.
What? W, angle W, right?
Oh, angle W.
So it would be angle A, right? Angle A. So angle A is 105. So 105 would be your answer, correct? Okay. Okay. All right, cool. We're done for the day. We're done for this half of the day, I guess.